and then come to the share screen. And I'm coming to R. So can you see my R screen here?
Yes, sir.
Okay, sorry for the interruption. There has been a lot of hailstorm and rain, and it disconnected me. So let us again, now we want to do the cluster analysis. We started it, but I'll again start it, cluster analysis. So first, let us do the cluster analysis. So first, locate the directory. So we'll say locate data file. So basically, we have to, because I have to shut down the computer. So send directory again, documents. So statistical hydrology 21. R notes and principal component cluster analysis. Okay. Okay, so that's the directory where my data is located. So now first is we have to read the data file. So data, say we are telling data 3.read.csv pca dat.csv header equals T. So PCA that is the data file name .csv, and yeah, that's, I think that should be all right. So that is our data. We read the data and we attach the data 3, and we want to tell this data as X. So our X matrix is really the data 3, and we want to scale the data, which we call X scaled equal, because in cluster analysis, different variables are measured in a different way. So it is better to scale the data. So XSC equals scale of or X data. So I think a scales, it should be a scale, not a scales. Okay. So scaling has been done. So now we can do the principal component analysis. So in cluster analysis, there are many different types of cluster analysis. So say complete linkage, average linkage, single linkage, this kind of technique. So let us do first the complete linkage. So HC hierarchical clustering dot complete COMPLET dot complete equals Hayes CLUST. So hierarchical clustering function is Hayes CLUST, Hayes clust. So that is the function, and then we have to say this is the command dist. That means distance, how we are measuring. So XSC our data that we want to do our cluster analysis, and then our method is complete. So in this command, HC complete, so we can write anything what we want in before, because Hayes clust, so that must be written in that way. Dist, and our data is XSC, and method is complete. So that is really the cluster analysis for complete linkage method. So we can do other one as well. So let us do the other one, which is Hayes-C average method. AVERAGE average, and here the method will sense, method will be, so average link is a VERAG average link. So this is the way how we measure the distance between different objects in multi-dimensional space. So then that will be done, and then we do the single linkage method as well. SINGL. So I'm using my arrow button to go backward, and then I'm trying to correct it. Correct it means they modify it. So that would be my method is average. No, this one is single. SINGLE. So HC single equal H class, this method is single. So that's fine. It should do. So I have done all this cluster analysis, and we want to plot the results in the plots of the results of the, we want to see the diagram. So what will say? Plot. What we want to plot? First one, HC dot complete, comma, and the main axis title will tell is the main axis title, or the plot title is the complete linkage. There is the complete linkage method, and we can put the label of the x-axis xlab. Because it seems nothing, comma, sorry, no space. Subheadings, SUB sub equals, and comma, CEX. Equals 0. So that's the kind of thickness of the lines in the plot. So I think that should be okay. So you can see here now. So can you see the plot of the data?
Yes, sir.
Yes, sir. Yes, sir.
So you can see there are two definite clusters, and the membership numbers in the clusters are there. So if we consider two clusters, then you can cut the line. So, but really this program helps you to cut the tree depending on if you want to make it 2 cluster or 3 or 4 cluster, they will help you to cut it. So we can cut the tree by this command, CUT, CU cow trees. So I have to say CUTREE. So cutting the tree of HC dot complete, and we can see that we can make it into 2 groups, and first group our members will be coming like that. So okay, so the we'll say that we want to make it 2 cart. We can make it 3 cart, 4 cart. So let us do 2 cart first. So our cart is 2, so complete, and then you want to cut into 2 groups, and then basically it will give us the membership really that in one. So according to the beginning of the data set, our first data point is going, first, second, all are going to the group 1. You can see from the right side that really your 1 and 2 is on the same group of the data. 2, 1, 2, 3, you can see all they are in the same group. And then, so it's really giving you the group membership, that which data, which catchment is which group. It's grouping the data for, if you want to do it for 4 cart, 4 group, Even we can do 3 as well. We can do 4, 3. Let us do 3. So basically in this command, basically we have to put 3. Then you'll see that 1, 2, 2, 2. First catchment is coming to group 1, second catchment group 2, group 2, group 2, and so it has divided into 3. We can cut them into 4 groups as well. So then 4. And then you see that in the 4th cluster, there will be only few numbers. Only 2 catchments are in the 4th cluster, which is here 19 and 22. These are the 2 catchments they are in the 4, 19 and 22. So that is you can see the complete linkage plot like this. So if you want to get the other linkage, let me scan like the snipe it. Sniping tool. So let us do a sniping. So a new sniping. And I want to do this cluster analysis sniping. Okay, so I have to open that file again because I think I lost it. So documents. Okay, so statistical hydrology. And coming here.
So can I make one quick comments?
Just give me a second. Okay, so what's your comments, Ali Ahmad?
So from this cluster analysis like complete linkage, I do prefer here for 2 groups rather than 3 or 4 because 3 or 4 cluster regions or cluster groups reduce the number of sites in the region. So what do you think, sir? What is comments or suggestions?
Like in this case, probably I think the 2 groups will be better. But I just showed how you can divide into different types of groups. That's I just demonstrated. That's all. But in this case, 2 group is better.
Yes, yes.
And still, like in some groups, if the catchment number is too small, then because we have only 28 sites here. Yes. So, but this is a kind of demonstration. Generally, we will have a bigger number of catchments when you want to do the grouping.
Yes. Okay. Thank you, sir.
Share screen. Okay. I think it's giving some trouble. Controls. Okay. So can you see my screen again?
Yes. Yes, sir.
Okay. Okay, so we have done that for our complete linkage, our result, and then we can look at our average linkage result. So we can go back and we can really say plot Hayes average, AVERAGE average, and main heading of the plot would be average linkage.
But your R screen window is not showing.
Not shared?
No, your Word file is showing.
Okay, so then share screen. Okay, so you can see R now, is that right?
Yeah, it's okay.
So I am just modifying that thing. So I have given here the Hayes average on, and then main heading is like that. So it should do. So we'll get now the cluster analysis or grouping by another technique, another method. And then I can do the same thing for single linkage. So I can go there and do the AC single, SINGLE single, and our heading will change is the single linkage. Single linkage. So that will give us the 3 different methods of cluster analysis. So basically, again, we can divide the membership cut. We can do the cut, and we can find the membership for this each of them. So if we want to cut, for example, we want to do a cutting of the say Hayes average, and then say we do it 2 cutting. So that by that way, we'll be able to find out the group membership of the cluster members. So I think that is the way we do the cluster analysis. So let me copy it again for record, sniping tool, and previously we did up to cut tree on, so new. So we have done this part only new, Control C. We'll go to the Word document and we'll put it there. Okay, so that's the cluster analysis. I put it there. Okay, so now we come back to R again. And probably it might be a good idea to take a screenshot of this plot. Sorry, take a screenshot of this dendrogram just to put it there, just to have a sniping tool, and we do a new sniping, and we want to problem. I don't want this coming to my screen there. I don't like it. Okay. Now it's better. Okay, so share sniping tool, and then new. Okay, now I am okay. Okay, so basically I am taking this plot of the clustering thing there. So I'm going to just put it here. So okay, so I think that's all for today. We have done the cluster analysis as well. So today we have shown you the regression analysis, principal component analysis, and cluster analysis. So I believe these are useful techniques. These have a lot of application in multivariate statistical analysis, in higher level research and analysis of the data. So I hope it will be useful to you. So I'll put the notes in the views as well, and also in the YouTube channel as well. But today there have been a lot of disruption in the recording, I think. Do you have any question? Anybody has got any question? So Gokhan, have you taken the role for the students?
Yes, sir, I did. I completed.
Can you tell me who are the HDR students attending today?
Yep, 1 second. Amir, Nilüfer, Ali Ahmed, and Enver is not in the list, but he joined.
Okay. Okay, so that's good. So any of the HDR students, Amir, do you have any comment?
No, I think I'm good. Thank you.
So did you follow all the analysis, everything?
Yeah. Yeah, I enjoyed R, which is good.
R is very user friendly, and there are a lot of YouTube that you can watch. So if you type that cluster analysis in R, you will find many YouTubes there. They will explain all these commands. But I have a very good book that I follow. I think I recommended this book to all of you before, particularly an introduction to statistical learning with applications in R. An introduction to statistical learning with applications in R. Yeah. I have a PDF version with me, but I cannot put in the views. But if you need it, then when the university is open, you can get it a copy of this from me.
Sure. Thank you.
This is a very, very good book for all statistical analysis in R. It has many, many techniques.
It is, sorry, sir, it is only available on the hard copy or no soft copy?
It is also soft copies available. I have the soft copy, but the problem is I cannot put in the views according to the university copyright information. Oh, so what I can do, maybe I can email the version if it is possible. I will to the HDR students.
Yeah, that would be great for us, sir.
Thank you so much.
This book is very, very useful. Like it's really one of the best books that I have found. And really, I read these books almost line by line because it's so well written. And with all the advanced statistical technique, like I give you some of the examples, like what it's doing. First is doing the statistical learning at the beginning, which is basic. Then it's doing linear regression, all different types. Then classification, like all different logistic regression, all classification, K, cluster analysis, everything. Then it's a cross-validation, K-means cross-validation, leave one-out validation. One chapter. Another chapter is linear model selection and regularization. Then you have the moving beyond linearity, like the GAM model and all this kind of advanced spline modeling. Tree-based methods, vector machines, unsupervised learning. Really all of this is here. And with all the commands, everything with examples, explanation of the theory at the beginning, and then they have given the command and examples in so nice way that anybody can understand these books.
Yes, sir. It would be great if I have the subcopy.
Remind me if I forget. Remind me. Yeah.
Okay, sir. Sir, one quick clarification about our final exam. Can I make comments?
Sure, please.
So in our learning guide, it was mentioned that lecture or tutorial from 1 to 5 will be covered in the final exam. But you also mentioned that from our later lecture, like covering the ARR FFE model and some data from the ARR data hub might be covered in the final lecture. Am I right, sir?
No, I'm sorry, because I never said anywhere that only lecture 1 to 5 will be in the final exam. Where it is written, it is not written.
So it is mentioned in our learning guides.
No, it's not in the learning guide. Learning guide, final exam is covering everything.
Okay.
It's not in the learning guide. For quiz 1 and quiz 2, there is some limit that, okay, lectures 1, 2 or something.
Okay, so
but for final exam, always, it's everything.
Okay, so it will cover all these things.
It will cover everything. And next week, I will really give a summary of the whole subject. And then I will give some hints of the final exam. Okay. That will be very, very useful, because, you know, there's so many things, and I think there are so many things, of course. And I realized that when the quiz 2, almost 50% students failed. So I think quiz 2 repeat would be much easier, in my opinion.
So
today's quiz.
Another point is like EasyFit software or Flyke software practicing materials or tasks might not be covered in the final exam.
You have to use R. Every student has to use R, because R is freely available.
Yes.
R and Excel.
Yes.
No SPSS is needed, because SPSS is sometimes not easy to get. So I'll give the problem so that you have to use R and Excel. And of course, other software like IFD software, which is freely available, ARR, or FFE software, which is freely available. But I'll not give Flyke, because Flyke is not freely available.
Okay.
So I'll discuss all these things in the last lecture, which is next week, basically. We're coming to the end of the semester. Okay, so I think that's all for today.
Okay.
Well, yes. Stop share. So Gokan, we have a meeting, is that right, Gokan?
Yes, sir. Yes. You can end the meeting and I can join.
We can cancel and then we'll again join, okay?
Yes, sir.
Okay, so I'm stop sharing.
Thank you.
I am